Alright, so in the last video we saw how the formula for the arc length of a function was justified or explained. Now let's put it to use. So find the arc length of the graph of f of x equals x cubed over 6 plus 1/2 or 1 over 2x on the interval 1/2 to 2. So using this formula we get the integral, the definite integral of from 1/2 to 2 of the square root of 1 plus, and now we have to get the derivative of this. Now let's work this derivative out. This is f prime of x equals 3x squared over 6, so 1/2 x squared. And now let's look at this term here. If you treat x as being negative to the negative first power, so you bring up the x, okay? We're going to leave the 2 there, so it's 1. So this here we can treat it as 1 over 2 times x to the negative first, and if we take the derivative of that, we get negative 1/2 x to the negative second. So that is f prime. Now I'm just going to try and make f prime look a little bit cleaner so that it will be easier for us to handle in the integral here. So this becomes 1/2 x squared minus 1 over x squared. Okay, so that's the derivative of the function f of x. So now we're going to take this, put it in here, and then square the result of that. So this is 1/2 x squared minus 1 over x squared. All of that times 1/2, and all of that squared, and then taking the integral of all of this with respect to with respect to x. Okay. So now some more simplification that can happen. Okay. So when we square this, we're squaring the 1/2, which gives us 1/4. And then we still have this quantity in here that needs to be squared. Point, we end up with the integral from 1/2 to 2 of the square root of 1 plus 1/4. And I am going to just FOIL all of this out. So x squared times x squared is x to the 4th. X squared times negative 1 over x squared is x. It's just 1, but I get 2 of those terms, so I get negative 2. And then the last 2 terms, negative 1 over x squared times negative 1 over x squared gives me positive 1 over x to the 4th. There's a dx out here. And then I'm going to distribute the distribute the 1/4 and do some simplifying from there. Okay, so multiply out the 1/4, or distribute the 1/4 through everything, and the 1 and the 1/2 and the negative 1/2 here will cancel, and it will give me 1 over 4x to the 4th plus 1 over 4 x to the 4th, all in the denominator, plus 1/2 dx. Okay. And I'm going to keep on going, factor out 1/4 again. And nicely enough, this part right here actually factors really well. So the 1/4 there, and you get x to the 4th. Oh, excuse me, not x to the 4th, x squared plus 1 over x squared dx out here. Now, the reason that that's true, the reason that you may wonder why does this 2 just suddenly go away? Well, because when you multiply these 2 terms together, x squared and 1 over x squared, you end up with a term with a number 1. Okay? And then you do that twice and you get 2. Okay? So now we can take the square root of everything. So we can take this, oh, and there's, there should be a square here. So this expression factors down to this. And now we can take the square root of everything. The square root of 1/4 is just 1/2. And the square root of this quantity squared is, well, the square root of a squared is, of course, this, dx. And we can evaluate 1/2 and 2. This now I'll rewrite as that because it makes life a little bit easier for me to integrate, or at least to find its antiderivative. And this is 1/2 times x to the third over 3 minus x to the negative first all over, oh, I guess I don't have to divide by anything. It's just dividing by 1. Evaluated between 1/2 and 2. So once I do all that work, it's going to come out to be 33 over 16. Okay. And I'll leave it to you to do all of the arithmetic. And you know, in real life or even on an exam, you're probably going to use a calculator to do these calculations. But it's good to know how to work with this through something like this that's a little bit more difficult in the event that you don't get a calculator, or in the event that this shows up on a non-calculator type of question. Okay, but you know, the main concept is to use the arc length formula that we justified in the previous video. Thank you for watching.